Hello everyone, and welcome back. In this session, we finalize our bridge design from last time, and I will introduce you to the continue working workflow. We start again in the Zirkonzahn archive, where I have opened the same project that we used in the previous session, including the two saved setups. From here, we simply continue with opening the Zirkonzahn.Modifier software. Once again, we proceed with the usual login procedure. After selecting the correct user profile, the appropriate license package is chosen. Since the models were already articulated during the previous video, there is now the option to either load the original position or reuse our articulated position. In our case, the articulated orientation will be selected. As visible on the screen, the models are positioned correctly. Although the teeth placement could be performed again, this step is not necessary since two setups have already been prepared last time. Therefore, we click on Next and skip this step. Now we chose one of the setups and proceed with the module selection. To finish our bridge restoration, the dies and implants module will be used. At this stage, the margin lines can be drawn. In this example, I will create them manually. For better point placement, I usually keep the texture enabled while placing the initial points. Afterward, the texture can be toggled off to allow a clearer and more precise view of the scan surface. Next, it is important to check for potential undercuts. This can be done by viewing the preparation from the occlusal direction and verifying that the green margin line would not be covered by the die. If no undercuts are present, the Add button can be selected to continue with our next die. One convenient aspect of the modifier is that all margins can be created in a single step, allowing multiple dies to be processed quickly. Points are placed using the left mouse button. Once the margin line is complete, a double click closes the loop. Care should be taken not to extend the margin onto the root surface, so I reposition a few points slightly to ensure a clean margin path. After completing that step, we can draw the final margin. At this point, we can rotate our model to the insertion direction. This helps identify any undercuts. If you notice undercuts, clicking inside the margin allows small adjustments to the preparation margin. This approach also makes it possible to refine multiple margins efficiently within the same step. Once everything is correct, we continue with Apply. The software proceeds by generating the crown bottoms for the preparations. Before continuing, the tooth numbers can be confirmed to ensure that the correct teeth have been selected. Several parameters can be adjusted at this stage. By selecting Edit, it is always possible to return to the margin step and modify any of the margins if necessary. The insertion direction can also be defined. By selecting Set Insert Direction, a single insertion direction can be applied to all preparations. Another helpful option is Apply to All Crowns. Activating this feature allows parameter adjustments to be applied simultaneously to every crown. We can modify the parameters as shown in the crown video, and additionally, we can also block out undercuts from the margin if necessary. All these parameters can be controlled together or individually, which makes working with multiple dies more efficient. After confirming the settings, Next is selected. The software calculates and generates the minimum thickness. From this point forward, the teeth can be adapted to the crown bottoms. An adapt teeth slider is available to define how strongly the adaptation should be applied. After selecting the desired value, clicking Adapt Teeth performs the adaptation automatically. The teeth are now all adapted. If necessary, the undo function can revert the entire adaptation step and allow it to be recalculated with different parameters. Alternatively, right-clicking on a tooth allows for the adaptation only, or the adaptation and free modulation of that individual tooth to be reverted. This provides the flexibility to reposition the tooth freely if additional adjustments are required. Whenever two teeth touch the same minimum thickness and begin to intersect, the software automatically merges them together, simplifying even the most difficult situations. Individual teeth can also be adapted separately by right-clicking and applying the adaptation only to the selected tooth. After completing the adaptation step, we continue with the modeling section, where certain areas around the margin can be smoothed. In areas like these, it may be beneficial to revert the adaptation, move some of the tooth surface slightly outward, and apply the adaptation again to achieve a cleaner and more natural result. The pontic region can also be smoothed slightly. Particular attention should be given to hygiene. The surfaces should be shaped in a way that allows proper cleaning while maintaining a natural transition between the elements. At this point, the contact to the neighboring tooth should also be verified. There are two possible methods for adjusting contacts. Interdental contacts can be cut directly, or a brush tool can be used. The brush tool is particularly useful in situations where the restoration intersects with the gingiva, but these areas should remain untouched. By brushing only the desired region, the software removes material selectively while preserving the rest of the structure. The same approach can be used in the gingival area, and we can trim the pontic according to our desired value. Once we are content with the shape and design of our restoration, the workflow continues by selecting Next. The following step includes the Shrinking and Connectors mode. In this section, global or localized shrinking can be applied. Using the brush tool, selected areas can be slightly reduced if necessary. If the marked region needs to be inverted, simply right-click and invert the selection. After choosing a value, clicking Apply performs the shrinking. The next step involves creating the connectors. When you click on Connector, they are generated. Wherever our elements are touching, the modifier automatically selects the contact connector type. However, connectors can also be customized. Selecting a connector allows it to be deactivated or replaced with a different type, in this case the circular one. The connector can be repositioned, scaled, and adjusted according to the design requirements. Additional control points allow further shaping to strengthen specific areas if necessary. Some connectors can remain unchanged, since they will be refined during the final freeform stage. Selecting Finish completes the module. The bridge structure is now generated, which gives us the possibility to merge it. This command unifies all components into a single structure, allowing the restoration to be refined using freeform modeling. From here, the bridge can be sculpted and shaped further. The pontic region, for example, can be refined to achieve a more natural contour. Displaying the model simultaneously helps evaluate the tissue profile and allows certain areas to be extended slightly downward. This adjustment can create a controlled amount of pressure for proper tissue support. Structural strength should also be considered. In areas where additional support may be required, extra material can be added. Making the object slightly transparent is often helpful, as it clearly reveals where the restoration may require reinforcement. After completing the freeform adjustments, Apply is selected. The restoration can now be saved. Returning to the archive shows the final bridge scene, as well as the constructed bridge saved in the project folder. Okay, now let's jump back to our modifier scene and proceed with the continue working. After saving, we now have the option of selecting Continue at the bottom of the interface to return to the module selector. This feature allows multiple modules to be executed one after the other, directly within the same workflow. For example, we will now create a quick bite splint. I will, however, explain the bite splint module in more detail in a future video. Before generating the splint, the model undercuts can be blocked out. Additional objects can also be included in the blockout. For example, by pressing Ctrl and left-click, the bridge is added as well, visualized by the yellow color. Next, the insertion direction for the blockout is defined. Several options are available: to block out the model, blocking out but leaving the undercuts, or leaving the model unchanged. For this example, we will allow a small amount of undercuts for retention of our splint. After the blockout calculation is completed, manual adjustments can be made by clicking on Modeling. If certain areas appear too tight, a small amount of material can be added to reduce excessive undercuts and improve the fit of the splint. The margin for the bite splint is drawn next. It functions the same as any other margin tool in the modifier software. After completing the margin line, a double-click closes it. Several parameters can now be defined, including occlusal thickness, peripheral thickness, smoothing level, and minimum thickness. Selecting Apply initiates the bite splint generation. Once generated, the splint can now be refined using the freeform tools in modeling. However, one issue becomes apparent. The lower jaw is still in contact with the upper jaw. To create sufficient room for the bite splint, we open the articulator. You can, of course, for real clinical situations, also import the lower jaw with the correct open relation to the upper. But in this scenario, opening the articulator pin will suffice. Let's also put some medium values into our articulator table. Another helpful feature becomes available at this stage. When displaying the articulator, the system shows that the articulator pin is open, but the movement simulation may no longer be accurate. By right-clicking on the lower jaw and selecting Save Current Antagonist Position, the antagonist remains in the open position while the articulator pin resets to its neutral position. This allows movement simulation to function correctly again. With this adjustment completed, the simulation can begin. Running Cut Dynamic automatically removes contact points created during the simulation. Additional material can be added where needed. Any interfering regions will automatically be removed while Limit by Antagonist Dynamic is active. This ensures that the bite splint properly supports canine guidance. Once the splint design is finished, we click on Finish. Any holes created in the bite splint can be closed by the minimum thickness or left unchanged. The bite splint is now complete. After saving again, returning to the archive shows both the bridge scene and the bite splint scene, along with the constructed objects. From here, we can now jump back to our scene and choose another module which we can chain after the bite splint. For example, let's open the model maker so we can also generate our models for printing. Once again, I will show you the model maker in another video in more detail. In the first step, we can choose the model base type we want to use. For this demonstration, I will use the jaw aligners for easy positioning in the articulator later. An inclined high base is used for the upper jaw, while inclined low is chosen for the lower jaw. providing sufficient space for the models. After applying these settings, the base height is slightly reduced to avoid removing excessive parts of the model. Proceeding with the next step, we can extract the dies. The software reuses the margins from the bridge module. Several parameters can be modified, including the pin angle, ditch roundness, and ditch indent. Once the desired values are defined, Control and left-click allows these settings to be copied to the remaining teeth. We continue to the model creation. Now let's make a hollow model with a honeycomb structure and drainage holes. Clicking on Apply generates the final models. The modifier also automatically labels them with the selected jaw aligner configuration for easier handling after printing. The honeycomb structure, jaw aligner connection, drainage holes, and removable dies are all visible in the final result. After finishing, the scene can be saved. Saving the models as STL files also allows them to be oriented directly for 3D printing. Returning to the archive confirms that the model maker scene and the constructed models are available, all properly oriented for printing. And that completes the continue working demonstration. This chain of modules allows for endless possibilities within our modifier software. Now, with these first 3 videos, we have covered the basic functions of the modifier, and we can now build upon that knowledge by diving into the individual modules in the next videos. Thank you for watching, and stay tuned. Goodbye.